Hello and welcome to IGCSE-Tube. So this is part number 4 of chapter number 14, Organic Chemistry. Sorry, let me get the highlighter. All right, so this is part number 4. I have already done 3 parts, and so I really recommend watching those first before going ahead and watching this video, because you will need the concepts that I discussed, particularly in part number 2, in order to be able to grasp what's going on here. Alright, so in this video, I'll be talking about the different reactions that alkanes undergo. And so a quick recap, what are alkanes? These are saturated hydrocarbons. Saturated meaning they only have single bonds between the atoms. And the general formula of alkanes is CnH2n plus 2, where n is an integer that is greater than or equal 1. So now going to the main focus of this video, which is reactions of alkanes, the reactions that alkanes are capable of undergoing. So first and foremost, before listing those reactions, alkanes are low reactive. You need to know that. Why? Obviously, there is a reason behind that. That's because of the strong single bonds between the carbon atoms. So, as I said here, the alkanes are saturated hydrocarbons. Saturated meaning they have single bonds, and single bonds are relatively much stronger compared to double bonds, for example. And so when the bonds are strong, they're difficult to break and difficult to accommodate, are difficult to break in order for the compound to bond with another element. And that's why they're low reactive. Alkanes are considered low reactive because of the strong single bonds between the carbon atoms and the difficulty of breaking them in order for another element to bond with the compound. Okay, next, reactions of alkanes. There are different reactions, 3 different reactions that alkanes can undergo. The first is combustion. The second is substitution with halogens. Halogens are, let me get the pen. Halogens are, for those of you that are not familiar with the term, it is group 7 elements in the periodic table, like the chlorine and the bromine and all these different elements. And the third reaction that alkanes can undergo, excuse me, let me get the highlighter, is cracking. Okay, so in this video, we'll be talking about combustion. I don't think we will have time to discuss substitution and cracking in this video, so these will be in part number 5, mainly because I want to keep the videos kind of short, like in the range of 5 to 7 minutes, in order for you, because, some of you might get bored or something, so when you break huge chapters into smaller videos, it's much better. Anyways, back to our subject, combustion. Okay, the characteristics of alkanes when they undergo combustion or when they burn is that they burn easily, they burn with a blue flame, and much heat is given out. So these are the 3 different characteristics that characterize the combustion of alkanes. You need to keep those in mind. And just before going to the next page, I have done a video on how you can maximize the benefit from my channel. I don't know if you've watched this or not, but if you haven't, one of the tips that I give is to have a copybook or a notebook and just write down everything that I mentioned in order for you to be able to have a really quick revision right before the exam. So this is something, for example, you want to write down the characteristics, the different reactions that alkanes undergo, basically everything, just write it down. Okay, so combustion. So there are 2 different types of combustion. There is the complete combustion and there is the incomplete combustion. What is the difference? The difference is that in the complete combustion, there is enough oxygen, to react with the alkane. While in the incomplete combustion, there is no enough oxygen. And as a result of this, different products are given out. So in the complete combustion, carbon dioxide, let me get the pen just in case my voice isn't really clear. So the products that are given are carbon dioxide, meaning di here means there are 2 oxygen, dioxide, so you have 2 oxygen, and water. Whereas in the incomplete combustion, where there is no enough oxygen, the products that are given out are carbon monoxide. So mono here means oxide, mono means there is only 1 oxygen atom, plus of course the water as well is given out. So let's see here some examples. So I listed 2 examples for each. The first is the complete combustion where there's enough oxygen. So here we have methane because there is only 1 carbon atom, and as I said, when it is 1, there is no need to write this subscript. And so this is methane. So it reacts with the oxygen and it gives out carbon dioxide and water. Now, balancing the equation is a whole other different chapter, which is the stoichiometry. And so I won't be, I haven't done a video yet on that, but yet I still want to explain how to balance the equation just because I haven't done a video yet that I can tell you, oh, you can go and refer to that. So you will look at your compound, which is the methane. You don't alter or modify the coefficient of the methane. So these 3 coefficients, by the way, for those of you that don't know, are basically the numbers in front of the compound. So you can alter the coefficients of oxygen, carbon dioxide, and the water, but not the compound itself. So here you have 1 carbon atom. So the first thing to modify is carbon dioxide. So you put here a 1. Or you don't need to put it, as I said, because as a subscript or a coefficient, you don't need to put a 1. It's understood that it is a 1. But anyway, so you put a 1 here. And then you have 4 hydrogens. So you go to the water. The next step is you go to the water. And as you can see here, we have 2 hydrogen atoms. And so what you have here 4. So you need to balance the side because this is the side of the reactants. Okay, let me get the eraser. These, no need to write this. So these are the reactants. And here, all of these are the products. All right. So you need to balance them. Like if you have here 1 carbon, there need to be here 1 carbon. If you have here 4 hydrogen atoms, there need to be here 4 hydrogen atoms. So you already have 2. What is multiplied by 2 that would give you a 4? Obviously, it's a 2. So now you're done. You're done balancing the carbon and done balancing the hydrogen. Count in the products side. Let me get the highlighter. In the product side, count the number of oxygens. So here you have 2. Oh, it's not the highlighter. I'm sorry. Okay. So you have 2 oxygens. And you have here, since this is 1 and you have here 2, so the total is 4. 2 plus 2 from here, so it's 4. And so you go to the reactant side. How many oxygens you already have? You have 2. And so what number do you multiply by 2 in order to get a 4? It's a 2. So it will be 4. So here goes, it's balanced. Okay, another example just to let everything sink in. We have here the heptane. This is called heptane because it has 4 carbon atoms. We have, oh my god, it's the yellow. I struggle. Okay, so the heptane, as I said, you can go to part number 2, and I discussed how to name the different alkanes based on the number of the carbon atoms. So here we have 7 carbon atoms. So the first thing is you go to carbon dioxide. So you have here 1, obviously, and so you multiply by 7 directly. The number which is here directly goes as a coefficient of the carbon dioxide. And then you have 16 hydrogen atoms. So the next step is you go to the water. So you have already 2. So what multiplied by 2 would give you 16? It's an 8. The third step is count the number of oxygens. So when you count, it is 7 times 2 is 14 plus 8 times 1, which is an 8. So sorry, my handwriting is, I need to get an eraser and just like clean everything up. Okay, let's see. So you have 7 times 2, it is 14, plus the 8 times 1, it's an 8. So the total is 22. So you go to the reactant side. How many oxygens you already have? 2. So what's multiplied by 2 would give you the 22? It's 11. and that's how you get it balanced. Okay, now to the incomplete combustion, I have another 2 examples. So the first example also is methane reacting with oxygen. Obviously, I said in the incomplete combustion, no enough oxygen. This cannot be expressed or seen from the formula, like in terms of the oxygen. But how to know it's an incomplete combustion? When you see carbon monoxide. That's the only way you can distinguish between a complete combustion formula and an incomplete combustion formula. That you will see here carbon monoxide, and here you will see carbon dioxide. But in terms of oxygen, you won't be able to say, oh, that's enough oxygen, that's not enough. You know it by the carbon monoxide or the carbon dioxide. Anyways, so going back to balancing that. So it's the same rule goes for these for the incomplete combustion as well, for the balancing. So you have 1 carbon. So obviously here the carbon monoxide, you also have 1 carbon. And so there is no need to add any coefficient here. You don't need to add the 1. And then for the hydrogen, you have 4. And so you go to the water, step number 2. You have already 2. What multiplied by 2 can give you a 4? It's 2. Now count the oxygen. When you count the oxygen, there's 2 here. 2 times 1 is 2, plus the 1 here. So you have 3. Now, the problem here is you have oxygen and you already have a 2. And you want to multiply it by something that would eventually give you a 3. Because here on the product side, you have 3 oxygen atoms. So again, so you have oxygen and you want it to be 3. Okay, so there is no any like an integer. Integer is, by the way, meaning a whole number, meaning not a fraction. Not a fraction. This means a whole number, not a fraction. These are all synonyms. Integer, whole number, not a fraction. So you cannot multiply any integer here that will give you a 3 by 2. It has to be a fraction, so it will be 3 times 2. Because when you multiply 3 times 2, you guys need, like for chemistry, that's something like off topic, not super off topic, but anyways, when like for chemistry, you need to also have like good math skills, like honestly, like if you want to get a good grade, you need to work on your math and algebra, not like super crazy calculus things, but just like basic algebra, and be good in that. So anyway, so 3 over 2 times 2, you will just get 3. Okay, now there is another point. So now that's a fraction. In some books, they like to express, they don't like the coefficients to be in fraction form. So what they will do, let me get another color, or just, let me clean up, because this is so like very unclean. I'm sorry, you guys, but I hope like so far everything is like clear. Okay, so in some books they say don't express the coefficients in fractions. There is nothing wrong with that, but just like, you know, it doesn't look good, or as good as like, you know, whole numbers. So what they do is they multiply the entire equation, in this case, to remove this fraction. Again, as I said, this needs like good algebra basics. So in algebra, if you want to remove the fraction, you multiply by the denominator of the fraction. So basically you multiply by 2 in order to cancel the 2. So if you multiply this equation by 2, you will get 2CH4 plus 3O2 and 2CO plus, let's see, it is 2 times 2, so it's 4, plus 4 water. So this equation is exactly identical to this one. Okay, it's exactly the same. The only thing is you didn't want a fraction to be, to have a fraction as your coefficient. Now, you will tell me, when do I need to do this extra step? If in the exam it is not mentioned, like to have the coefficients as integers or like whole numbers, you don't need to do this extra step. But if they ask, definitely you need to do it. And the thing is, the only difference is, you know, they might have, okay, let's say they have CH4 plus O2, and it gives you carbon monoxide plus water, the same example we had. And then he puts A, B, and C. Yeah, A, B, and C. And he tells you A, B, and C are integers. Okay, find them. So in this case, you need to do that extra step, and that is express it in fraction first if necessary, or because it's an odd number, the number of oxygen atoms are odd, so you need to express it in fraction, and then do the step that I told you about, and that is multiply the entire equation. Some people do the mistake of just multiplying the oxygen part, which is totally wrong. You need to multiply the entire equation by the denominator to give you an equation that has like full integers. And obviously there will be also here a coefficient, so let's name that a D because I already named A, B, and C. Okay, anyway, so let's go to the next equation. This is 5 carbon atoms, meaning it is, let's see, oh my god, I forgot. No, it's octane, I guess. Yeah, no, not octane. Octane is 8. Oh my god. Where's my mind? It's not octane, you guys. So, oh, this is so bad. Oh, pentane. Oh my god. So this is pentane. So yeah, this shows you that even like I forget things. I don't have the best memory ever. But anyways, so this is a pentane, and it reacts with oxygen, as we said, and gives carbon monoxide and water. Obviously, carbon monoxide here signals the fact that it is incomplete combustion. There is no enough oxygen. So you have 5 carbon atoms. Okay, let me clean up again. I don't know why I'm being very not patient with the fact that I'm not clean in this video. So that's oh my god, I delete everything. So that's a pentane. Anyways, let's go back to the highlighter. So first thing, you'll balance the 5. So you have here 5. Again, it's not the highlighter for some reason, you guys. Okay, so you have 5. So you go here and put a 5 in front of the carbon monoxide. The second step is to balance the hydrogen. So you have here 12. What's multiplied by 2 would give you a 12. Obviously, it's a 6. Now count the oxygens. So you have 5 times 1 is 5. Plus 6 times 1, obviously, it's a 6. So 5 plus 6 is 11. Again, 11 is an odd number, so you'll need to multiply, and you have here already 2. So you have to multiply by 11 over 2. Again, if you want all the coefficients to be expressed in whole numbers and not fractions, you multiply the entire equation by 2, because this is the denominator in this case. One quick note, carbon monoxide, obviously, if you don't know, it is toxic. It's a toxic gas, and it causes oxygen starvation in the blood, so it's pretty dangerous. So that's why incomplete combustion isn't really preferable. Okay, so I think I'm going to end the video here. Thank you very much for all the support and the comments. Really, the comments is what keeps me going. And, knowing that I'm helping you guys, the only sole purpose of me doing these videos is basically to help people out, to help students that are having a hard time understanding these concepts. And so when you leave comments telling me, oh, this benefited me a lot, that's a huge thing for me, more than you can ever imagine. So I would really appreciate it if you leave a comment. Obviously you can ask any questions, don't hesitate to leave them. And also if you can give this video a thumbs up. And thank you very much, and see you in part 5, where we'll be discussing the 2 other reactions, which are substitution and cracking.